Hello students, welcome to mathematics class. Students, this is part 9 of the chapter comparing quantities. In this we will revise deduction of formula for a compound interest. So, this video you are going to watch on 8th January 2021. Coming to the now, what is deducing? Deducing is just nothing but deriving a formula for compound interest. Here I will derive using one example. Let us consider Zubeda asked her teacher, is there any easy way to find compound interest? Then the teacher replied, there is a shorter way of finding compound interest. Let us try to find it. Then suppose P1 is the sum on which interest is compounded annually at the rate of R% per annum. To find this, we have assumed let P1 is 5000 and rate of interest R is 5%. Now, you will find simple interest, let me say interest 1, I1, that is interest for the first year, is calculated with the help of formula PTR by 100, PTR by 100, T is for 1 year, R is 5 by 100. Here I have taken I1 formula as PTR by 100. Since it is interest for first year, I have considered principal for the first year. Okay. Now, after simplification, we have got 250 being the interest for the first year. Now, see children, normally if I want to find amount by the end of first year, then I have to add to the principal for the first year this amount for the first year, like by substitution P1TR by 100 formula, that is I have to 5000 plus 250, that I can take like this 5000 into 1 into 5 by 100. Here I have already given a formula for you by taking P common, that is 5000 if I take common, I will have 1 plus 1 into 5 by 100, where this 5000 comes out as a common. Similarly, see children, the same thing I am using for the sake of A1 is P1 into 1 plus TR by 100. This is amount by the end of first year. Now, P2 will be the amount by the end of first year, that is it is P1 times R 1 plus TR by 100 becomes principal for the second year. Now, amount for the second year will be this P2 multiplied by 1 plus TR by 100. This is P2 times of 1 plus TR by 100. Now, if I substitute P2 value from this, let me say this is equation A. If I substitute that, then let me write in next page. Amount by the end of second year is principal for the first year into 1 plus TR by 100 into 1 plus TR by 100. How I got? Since P2 is P1 times of 1 plus TR by 100, I am substituting in the place of P2. Okay. So, therefore, it becomes P1 times of 1 plus TR by 100 into 1 plus TR by 100 is 1 plus TR by 100 whole to the power 2. This is amount for the second year. Now, what is this T? T is always 1 because we have, even in the earlier case also, this T is becoming for the 1 because it is 1 year. You watched here, T is 1 year for the 1 year. Okay. That means ultimately here this T being 1 gives us P1 times of 1 plus 1 into R is R by 100 whole raised to the power 2. This is amount at the end of second year. Now, what about amount at the end of third year? Amount at the end of third year is supposed to be P3 times of 1 plus 1 into R, that is R by 100. But what about P3? You know, P3 is amount at the end of second year. Amount at the end of second year, I have got, it is being equation B. I am saying this is amount at the end of second year is this. So, I can substitute here. P3 is P1 times of 1 plus R upon 100 raised to the power 2. If I substitute here, P1 times of 1 plus R upon 100 raised to the power 2 into 1 plus R upon 100. So, it becomes amount end of third year is P1 times of 1 plus R upon 100. Now, square into 1 time becomes 3, 1 plus R by 100 whole raised to the power 3. Now, this is amount at the end of third year. It will be now principal for the equation C. It will be the principal for fourth year. So, continuing further like this, I can say amount by the end of nth year is P1 times of 1 plus R upon 100 whole raised to the power. You watch, for the second year power is 2. For third year, amount end of the third year power is 3. So, amount at the end of nth year will give 1 plus R by 100 whole raised to the power n. So, this is the formula to calculate amount in the case of compound interest. Okay. Here P1, which I can say instead of P, principal, and can be substituted as P, and rate, it is rate of interest, normally given as R%. Okay. Rate of interest per annum, normally we will have, instead of per annum I will tell Further, normally rate of interest per annum will be given. It is per or for the time period, for the time period of calculation, or for the time period of we have one term which I have to explain you. So, I am using till then for the time period of calculation, and here n is number of years at present I will tell, but there is another term which I have to use. It is, as of now, it is number of years. So, this is the formula to find amount in the case of compound interest. Suppose if you are asked to find compound interest, if someone asks you, then from this amount, here I did not write what is AN, let me write amount by the end of n years, or for that time period n after n times calculation. So, from that amount I have to subtract the principal, that gives compound interest. So, compound interest is amount minus principal. You will first find amount, then subtract from that principal, you will get the compound interest. Now, let us get into the example and solve a question. Here, so Zubeda said, but using this we get only the formula for the amount to be paid at the end of n years and not the formula for compound interest. That is obviously, but Aruna at once said that we know compound interest by subtracting principal from the amount, we can easily find the compound interest too. So, coming to the example, here compound interest on rupees 12,600 for 2 years at 10% per annum compounded annually to be calculated. Here principal is 12,600, rate of interest is 10% per annum, and time period is 2 years, and compounded, very important children, compounded annually. Here you have to observe, is it compounded annually or not, you have to very carefully observe. Therefore, if it is compounded annually, therefore n becomes 2, and from the formula amount equals to principal into 1 plus rate of interest by 100 raised to the power n. On substitution, 12,600 into 1 plus 10 by 100 raised to the power 2. 0 0 cancels, 1 plus 1 by 10, you know 1 plus 1 by 10 is 11 by 10, 11 by 10 whole square into 12,600. You know how to simplify it. If you simplify, you will get the amount as 15,246 rupees. This is amount. But how to find compound interest? If you are asked to find compound interest, I have to subtract. Compound interest is 15,246 minus 12,600. You know, you will get 2,646 rupees being the compound interest. So, subtract principal from the amount that you have calculated and you will get easily compound interest. So, this is the use of the formula that we have derived. This much easily we can find. Now coming to the another important concept. Here try to observe children, we are asked to find the compound interest on a sum of 8,000 rupees for 2 years at 5% per annum. So first here principal is 8,000 and rate of interest is 5% per annum compounded annually. Then time period given is 2 years. Since it is compounded annually, therefore n becomes 2. Now as per the formula, amount is equals to principal into 1 plus rate of interest by 100 raised to the power n. Now on substitution, 8,000 into 1 plus 5 by 100 raised to the power 2. You know 5 by 100 gives 1 by 20 and 1 plus 1 by 20 is 21 by 20 whole square is multiplied to the 8,000. Now you know how to simplify 8,000 into 21 by 20 into 20. This 2 zeros I am cancelling and this 2 40s and 2 20s. We have 20 into 21 into 21 is 441 and 20 into 441 is 8,820. So this is the amount by the end of 2 years. Therefore compound interest is amount by the end of 2 years minus principal, that is 8,820 minus 8,000 gives you 880 rupees being the compound interest. So this is how we calculate. Now from this formula I have further need to discuss with you one more important topic called rate compounded half yearly. Instead of annually I have half yearly. Annually you have already learnt. Now you need to know half yearly. This half yearly is also called semi annually. See children, the formula is very well known to you. This is the formula. Remember here principal, this is amount, this is principal, but there is a special name for R and special name for N, which I am going to tell you. Remember children, here this time period and rate when interest not compounded annually, the time period after which the interest is added each time. If it is compounded half yearly means after every 6 months. After every 6 months interest will be calculated. Interest will be added by calculating interest will be added to the previous principal. Okay. So for every 6 months once I have to do this process. That 6 months we call it as conversion period. Okay. That conversion period. Remember that conversion period tells this half yearly. This is conversion period. Conversion period. That means for every 6 months once I have to convert principal into amount, and that amount will serve as a principal for the next conversion period. Understood? So, first interest will be calculated, added to the previous principal, that amount will come, that amount will be new principal for the next term. So, this conversion period is very important. Children, now when interest is compounded half yearly means there are two conversion periods in a year. How many conversion periods are there in a year? There are two conversion periods. That means each after 6 months we will get that. In such situation, half yearly rate will be half of the annual rate. This is the term which I am taking, rate of interest for a conversion period. Remember, which is very important, rate of interest for the conversion period, So, this R is not rate of interest per annum, it is the rate of interest for the conversion period. Very important. These two things will change when compounded half yearly. R will change, N will change, principal will remain same. R will be rate of interest for the conversion period. Now, what is N? Remember children, number of conversion periods that exist in the time period. Okay, for how many years you have taken, in that number of years how many conversion periods are there. For example, in 1 year there are two conversion periods, then it becomes N as 2. Suppose if you have taken for 2 years, then conversion periods are 4, then N becomes 4. Understood? So, this is very important. Number of conversion periods that exist in the time period will be N, and rate of interest for the conversion period will be R in this formula. Okay. Now, we will solve one question on this concept. Here I am giving one example. Suppose principal is 100 rupees and 10% per annum compounded annually. Then time period is 1 year, interest is using formula PTR by 100, if you find you will get 10 rupees, and amount will be adding principal and interest will give you 110 rupees. But whereas compounded half yearly with the same principal 100 rupees and 10% per annum as compound interest rate, now time period for every 6 months, that is for half year, you have to find interest, that is 5 rupees is interest. For the first 6 months you are adding that. Now 105 is amount which is going to be the principal for the next 6 months, and interest for the next 6 months is 5.25 rupees, that is 5 rupees 25 paise. Now it is added to the amount, gives 110 rupees 25 paise. See children, here very important, this process you are doing for every 6 months once. Now try to observe what is the rate of interest here. Here the rate of interest is getting halved, isn't it? For half yearly, where 10% per annum rate of interest is getting into 5%, it is getting halved, isn't it? Here rate becomes half for half yearly. Okay. So, thus if the interest is compounded half yearly, we compute the interest for 2 times. So, time period becomes twice and rate is taken half. So n becomes 2 and r becomes half of the rate of interest per annum. Suppose in that formula, if I substitute same, that is 1 p into 1 plus r by 100 raised to the power n. Here p remains 100 rupees only, but r becomes 5% and n becomes 2 because compounded half yearly. Now amount is 100 into 1 plus 5 by 100 whole to the power 2. On simplification, it is 1 by 20. 1 plus 1 by 20 is 21 by 20. 21 by 20 whole square is 100 into 21 square is 441 by 20 square is 400. These two zeros will get cancelled. 441 by 4 is 110 rupees 25 paise. So that's how amount comes straight away. Okay. Now let us find what is n and what is r for the given data. Here in this, try this, find the time period and rate. A sum is taken for 1.5 years at 8% per annum, but compounded half yearly. So time period and rate of interest you have to find. Here time period n is 3 times half yearly will come in 1.5 year, half years will come for 3 times, so n is 3, and rate of interest 8% per annum, for half years it is 4%. Okay, 4% per 6 months. Then in the second question, again it is half yearly for taken 2 years, so n becomes 4 and rate of interest 4% per annum, that means 2% for 6 months. So this is how we get r and n value based on the given data. Now we shall solve a question on this. Question number, example number 12. What amount is to be repaid on loan of rupees 12,000 for 1.5 year at the rate of 10% per annum, compounded half yearly? Here principal is rupees 12,000, whereas rate of interest 10% per annum, and therefore compounded, here compounded half yearly, therefore n equals to 2 and r equals to 5%. Okay, if once we got this, amount equals to principal into 1 plus r by 100 whole to the power n, where 12,000 multiplied to 1 plus 5 upon 100 whole power 2, on simplification you know it is 21 by 20 whole square is multiplied to the 12,000, and you know how to simplify, children. Here amount equals to 12,000 into 441 by 400, 2 zeros will get cancels, 4 30s, so 0 3 1 3, 12 1 13, so it is 13,230 rupees is the amount what we have got, but this is for 2 years. Oh, I have calculated for 2 years. Sorry, this is for 1 year. Amount by the end of 1 year. Okay, by the end of 1 year. I am supposed to calculate it for the 1.5 year. I have not written that, that is why I went wrong. Time period is 1.5 year. So, let us calculate that. Okay, I will take a new page and do this. Principal is 12,000, time period is 1.5 year, and rate of interest is 10% per annum compounded half yearly. That means, therefore, n is 3 times and r in the formula a equals to p into 1 plus r by 100 raised to the power n. In this formula we have got r being 5% for 6 months. Now 12,000 into 1 plus 5% by 100 whole to the power 3. So, 12,000 multiplied by 21 by 20 cube. So, 12,000 into 21 by 20, 21 by 20 into 21 by 20. So, these 3 zeros will cancel with these 3 zeros. So, 2 ones are 2 6 are and 2 ones are 2 3s are. I have got finally here amount being 21 cube into 3 by 2. You know how to find 21 cube. So, 21 into 21 into 21 is 9,261 multiplied by 3 by 2. 9,261 into 3 is 27,783 by 2, where it gives 13,891 rupees 50 paise. This is amount by the end of 1 year, amount by the end of 1.5 year. So, this is how we calculate amount by the end of 1.5 year when we are given 10% per annum compounded half yearly. Now, children, here I am giving you homework for you. Homework for you is at the end of second year on 2,400, 5% per annum compounded annually. See, compounded annually for 2 years. You know how to find. N equals to 2 and R equals to 5% only. But compounded quarterly. Here quarterly means what? Quarterly means for every 4 months. For 3 months. So, quarterly, there are 4 quarters in a year. So, for 1 year, quarterlies are 4 in number and rate of interest 8% per annum becomes 2% per annum because 8 by 4. So, 4 quarters for 12 months rate of interest is 8. For 3 months rate of interest will be 8 by 12 into 3, 3 ones are 3 fours are, so 8 by 4 is 2%. So that's how this 2% comes. Okay, so you do this as homework, and here question number, example number 13, I will solve and wind up this session. Find the compound interest paid when a sum of 10,000 is invested for 1 year and 3 months, were compounded annually at the rate of 8.5%. See children, you cannot have, when it is compounded annually and time period is 1 year 3 months. So what to be done? In this case, first find amount end of the 1 year, find amount by the end of 1 year. How do I get 1 year? This whole part. So amount by the end of 1 year is principal into 1 plus r by 100 raised to the power n. Using that, here compounded annually, then we will have n being 1, rate being rate of interest per annum only, that is 8.5% per annum only. So 10,000 into 1 plus 8.5%, it can be said as 17 by 2. So 17 by 2 comes and multiplies 100, so it becomes 200. 17 by 200 raised to the power 1, and it is 10,000 into 217 by 200. So 2 zeros will cancel, 2 ones are 208.5. so 100 multiplied to this becomes 0.850. That means 10,850 becomes amount by the end of 1 year. Now calculate interest for that fraction part. For that fraction part is 3 months. So interest for 3 months, if you calculate by using this, becomes principal for the fraction part. Okay, so here principal is amount in that whole part, which is 10,850. Now interest is 10,850 into, we know here we have got rate of interest again same, 17 by 100 into 2, that 17 by 2 comes into the denominator, into, now here what do we get? Rate of interest 3 months in 1 year is 1 by 4 year. So 3 months is nothing but 1 by 4 year, that you can straight away substitute here, 1 by 4. Now on simplification, you will get interest as 230 rupees 56 paise. Now this will be added for that time. So amount is equal to 10,850 plus 230 rupees 56 paise, put together 11,080 rupees 56 paise. So 11,856 paise, and initially it was 10,000, so the difference is 1,080 rupees 56 paise is the compound interest. This is how we solve this sort of questions. These questions are very important, where whole part and fraction part is given in time period. Whole part in years, fraction part sometimes in months will be given like this. So, wishing you good luck for solving exercise questions of 8.3. I have one more topic to revise, that is applications of compound interest. We will see in our next class. Wishing you good luck. Take care of yourself. Jai Hind. Thank you.